Good evening, everyone. This is the assignment related to topic moles and acid. In the last session, we discussed 15 questions, and today we discuss 15 onward. So, in the first question, Avogadro constant is equal to the number of. So, how we can work out Avogadro constant? Avogadro constant means 6 exponent 23 or 6.02 into 10 to power 23. That's Avogadro constant. That is equal to atom in 1 mole of any element. That will not be true because some of the elements are diatomic, some of the elements are monoatomic. So it is true for monoatomic, but it is not true for diatomic, because in diatomic the number of atoms will be twice as compared to number of molecules. So it cannot be A. What about B? Atoms in 1 mole of monoatomic. That's true because the number of the moles, the number of atoms which are present in 1 mole of monoatomic, like if I say I have 1 mole of helium, so it will have 6.02 into 10 power 23 atoms. But about oxygen, like if I say I have 1 mole of oxygen, that it will have 2 times 6 into 10 power 23 atoms. It will have same number of molecule, but the atoms will be twice, as one molecule contain 2 atoms. That's why B is the right answer. What about option C? Atom in 1 mole of any compound. That's wrong because the compound may have different number of atoms, so totally wrong. Ions in 1 mole of ionic compound. That cannot be true because if you have NaCl, so if you have 1 mole of NaCl, it contains sodium ion and it contains chloride ion. So the ratio of molecule is to ion is 1 is to 2. So it will not be correct. In the next question, 100 cm cube of methane is completely burned and 400 cm cube of oxygen. What is the final volume of a gas? Gaseous mixture in cm cube, and all the volumes are measured at room temperature and pressure. So first we'll write the balance equation. Methane, which is CH4, burned in the presence of oxygen to give carbon dioxide and water. So first balance carbon is already balanced, then we balance hydrogen by putting 2, and then oxygen 4 are there, so we put 2. So ratio between methane and oxygen is 1 is to 2. So if you have 100 cm cube of methane, x cm cube of oxygen will be there, cross multiply. So it means 200 cm cube of oxygen react. So how much oxygen will be unreacted? So 400 cm cube is total amount of oxygen. Out of 400, 200 cm cube is completely reacted. So how much oxygen is left? 400 minus 200. So that is 200 cm cube. And at room temperature, water will be liquid, carbon dioxide is gas. So the moles, the ratio for methane to carbon dioxide, the ratio is 1 is to 1. So if we burn 100 cm cube of methane, it will be x cm cube of carbon dioxide. So it will be 100 cm cube of carbon dioxide. So we are left with 200 cm cube of oxygen, and we are left with, or the amount which is formed for carbon dioxide, that is 100 cm cube. So total volume of a gas will be 300 cm. Question 18, in UK, the limit of gaseous hydrocarbon in vehicle exhaust is 200 parts per million. What is the maximum volume of a gaseous hydrocarbon allowed in 10 mole of exhaust gas? So we have concentration in ppm, that is, because moles are given, so here it will be moles of hydrocarbon, I'm writing in short HC, divided by moles of exhaust gas into 1 million. So concentration is 200. Moles of hydrocarbon we don't know. Moles of exhaust gas, that's 10 into 1 million. So we'll find x here. So x will be 200 multiplied by 10 divided by 1 million. So it will be 200 times 10, which is 2000, divided by 1 million, equal to 0.002 moles of hydrocarbon. But we need the volume, and that is in cm cube. So we know volume in dm cube is equals to moles multiplied by molar volume. So moles are 0.002 multiplied by molar volume is 24. So we multiply by 24, that will give us 0.048 dm cube. But we have to convert dm cube into cm cube, so we multiply by 1000. So 1, 2, and 3, so it will be 48 cm cube. So B will be the right answer for this. In question 19, this question is about the preparation of hydrated zinc sulfate. An excess of zinc is added to 20 cm cube of 1 mole per dm cube sulfuric acid. State 2 observation. So when acid is added to metal, what we'll observe? We'll observe, because hydrogen gas is there, so we'll observe fizz, bubbles or effervescence, and we'll observe the solid dissolve. Write an ionic equation. So here zinc, which is in a solid state, reacting with hydrogen ions in aqueous to give zinc ion in aqueous, and it will be hydrogen gas H2. This is the ionic equation for this reaction. Next question. When the reaction is complete, the zinc sulfate solution is formed. Some unreacted zinc is left. Describe how pure dry crystals of hydrated zinc sulfate may be obtained. So how we can obtain the pure and dry crystals of hydrated zinc sulfate? So first we have to remove the unreacted zinc. And how we'll remove the unreacted zinc? So we will first filter to remove excess of zinc or unreacted zinc. That's first thing. Then we will heat concentrate and concentrate the solution till point of crystallization. Then we will cool, filter, and we will dry the solid or dry the crystal. So to dry the crystal, we can use a filter paper or we can use a tissue paper as well. These are the steps we will follow to obtain the hydrated crystals of zinc sulfate from the mixture. The formula of hydrated zinc sulfate crystal is ZnSO4.7H2O. Calculate the molar mass. So how we can work out the molar mass? We have zinc here, sulfur is there, oxygen is there, and then water molecules. So using a periodic table, the mass of the sulfur is 32, whereas mass of the zinc is 65.6. 4. So that is 65.4. Sulfur is 32 plus oxygen is 16 multiplied by 4 plus water H2 hydrogen is 1 multiplied by 2 plus oxygen 16, so total is 18, and that is times 7. So this will give us the total mass, the molar mass of zinc sulfate, which will come out hydrated zinc sulfate 287.5 or 287.4 gram per. Calculate the number of moles of sulfuric acid in 20 cm cube 1 mole solution. So how we'll work out? We have the volume, so moles equals concentration into volume. The concentration is 1 and the volume is 20 divided by 1000. It will be 0.02. These are the moles of sulfuric acid. 4 gram of hydrated zinc sulfate crystals forms. Calculate the percentage yield. So if you want to, we need the practical values given. Theoretically, we have to work out, so theoretically how much mass of zinc sulfate is there. So we have to use the equation when zinc is reacting with sulfuric acid, H2SO4, it gives zinc sulfate and zinc sulfate plus hydrogen. So the mole ratio between hydrated zinc sulfate and sulfuric acid is 1 is to 1. So same number as the previous answer was 0.02. So if you have 0.02, we'll get the same number of zinc sulfate, and hydrated zinc sulfate will have the same ratio as zinc sulfate plus 7H2O will give us ZnSO4 dot 7H2O. So the ratio between hydrated and anhydrous zinc sulfate is same. So we'll get the same moles for hydrated zinc sulfate. And now we'll get the mass. To get the mass, we'll have moles multiplied by molar mass. So moles are 0.02 multiplied by molar mass, which we already worked out in the first part. That was 287.4. So this will give us the mass, the theoretical mass, which is 5.75 gram. And percentage yield is a practical value. Practically we are getting 4, theoretically 5.75 into 100. So when we solve this, the percentage yield will come out as 70%. In question 20, 2000 gram of a solution contains 0.015 gram of solute. Concentration in ppm. So concentration in ppm, mass of solute 0.015 divided by mass of solution 2000 into 1 million. 0.015 divided by 2000 into 1 million, we'll get 7.5, the concentration in ppm. What is the concentration in mole per dm cube? We had 10.6 gram of sodium carbonate in 250 cm cube. So first we have to get the mass, the moles of sodium carbonate, because we need mole per dm cube. So moles will be equal to mass in gram divided by molar mass. So sodium is 23 multiplied by 2 plus carbon is 12 plus oxygen is 16 multiplied by 3. So 46 plus 12 plus 48. So that will make 106. So 10.6 divided by 106, that's equal to 0.1. So we have the moles, the volume is in cm cube, we have to convert into dm cube divided by 1000, so 0.25. To get the concentration, that's moles divided by volume. So 0.1 divided by 0.250, that's equal to 0.4 moles per decimeter cube. So A will be the right answer. In question 22, a solution contains 33 parts per million of solute. The mass of a solute dissolved in 1 kilogram of solution. So how we can work out? So concentration in ppm, mass of solute divided by mass of solution into 1 million. So the concentration is 33 parts per million, mass of solute is unknown, and all the answer in gram, but here the solution mass is given in kilograms, so that will be 1000 into 1 million. So it will be 33 multiplied by 1000 divided by 1 million. This will give us the mass of solute. So basically it's 33 divided by 1000, which will come out as 0.033. So C will be the right answer for question 20. For question 23, the Avogadro constant is equal to the number gram of an element which contains 6 exponent 23 atoms of that element. That's not the right answer, because grams of an element which contains 6 exponent 20, it can, because element can be an atoms or it can exist as molecule as well. Atoms contain in 1 mole of any element, that's wrong, not 1 mole, but it is number of atoms which are present in 1 mole of monoatomic, so that C is the right answer. In 24, a hydrocarbon contains 82.7% carbon and 17.3% hydrogen. What is the molecular? So first we have to work out the empirical mass of empirical formula. So we have percentages. This is 82.7 and hydrogen is 17.3. So we divide this by 12 and 1. So 82.7 divided by 12, that's equal to 6.89. And this is 17.3. So we'll divide both of them by 6.89. This will be 1, and 17.3 divided by 6.89, this gives us 2.5. So whenever one of the value 2.5, 1.5 will multiply all of them by 2. So this will be 2 and 5. So the simplest ratio is 2 is to 5, but they're asking for molecular formula. So what could be the hydrocarbon, which is, because a hydrocarbon can be alkane, alkene or alkyne. So if it is an alkane, the number of hydrogen should be twice plus 2. So it cannot be C2H5. Why? Because it does not matches with any alkane, alkene or alkyne. When you check option D, 4 and 10 or ratio will be 2 is to 5. That's why D is the right answer. Why not B? B is even a correct formula, but it's not having a simplest ratio. It is 1 is to 2, not 2 is to 5. That's why D is the right answer for question 24. For question 25, calculate the number of atoms in 1 mole of hydrogen peroxide. So how we'll get the number of atoms? Because 1 mole of hydrogen peroxide, how many atoms are there? It contains 4 moles of atoms, because 2 hydrogen. So ratio 1 mole contains 4 atoms. So if 1 mole is having 6.02 or 6 exponent 23, then it will be x atoms cross multiply. So 6 exponent 23 multiplied by 4, that will come out as 2.4 into 10 to the power 24. So D will be the right answer. In question 26, when 0.1 mole of atoms of an element reacted with chlorine, there is an increase in mass of 7.1 gram. What could be that element? So how we can work out which element is there? First we should know the balance equation, like if magnesium is reacting with chlorine, it will form magnesium chloride. So 0.1 mole, what will be the mass of 0.1 mole? The mass of magnesium, that is 24, and mass of magnesium chloride, 24 plus 71, that's equal to 95. So 24 gram of magnesium will give 95 grams of magnesium chloride. If we have 0.1 mole, or 0.1 mole of magnesium, means if we multiply by its molar mass, it means we'll have 2.4 grams of magnesium. So if we have 2.4 grams of magnesium, how much magnesium chloride will be there? X. So this X will come out as 9.5 gram. So what is the increase in mass? If we have 2.4 gram, it will turn into 9.5. So what is the increase in mass? 9.5 minus 2.4. So the mass will increase by 7.1 gram. And basically, the increase in mass of 7.1 gram means like a molecule of chlorine is added to that element. So you can also work out by just writing a full equation, like when carbon reacted with chlorine, it will form carbon tetrachloride, CCl4. So basically 2 moles of chlorine will are added, and 2 moles of chlorine, 1 mole of a chlorine will have a mass of 71, but 2 moles of a chlorine will have a mass of 142. So it cannot be A. When you check for sodium, so here 2 moles of sodium are reacting, so the total mass will not increase. But when you check magnesium, 1 mole of magnesium react with 1 mole of chlorine to give magnesium chloride. That's why C is the right answer. In question 27, magnesium nitrate decomposed by heating the following reaction is there. In an experiment, 0.1 mole of magnesium nitrate is heated. What is the maximum volume of NdMq for the gas? So here, what is the maximum volume of the gas? So the two gases are there. One is nitrogen gas, one is oxygen. So the ratio first between magnesium nitrate and nitrogen dioxide, the ratio is 2 is to 4 or 1 is to 2. So if we have 0.1 mole, this will be X. So we'll get 0.2 moles of nitrogen dioxide. And the ratio between magnesium nitrate and oxygen, that is 2 is to 1. So if we have 0.1, this will be 0, this will be X cross multiply. So this will be 0.05. So total moles of the gas which we collect, zero point 0.2 moles of nitrogen dioxide and 0.05 moles. So the total moles will be 0.25. And then multiply by molar volume, which is 24. So moles multiplied by molar volume will get the volume. So 0.25 multiplied by 24 will get 6 dm cube of the gas. That's why D will be the right answer for this. Is it clear? Question 27. In question 28, ammonia decomposes when heated in an experiment. 500 cm cube of ammonia was heated and 20% decomposed. What is the total volume of a gas at the end of experiment? So total volume of a gas will be unreacted ammonia and the formed nitrogen and hydrogen. So what is the 20% of 500? So 500 multiplied by 20 divided by 100. So 20% of 500 is 100 cm cube. So basically 100 cm cube of ammonia decomposed. So how much ammonia is left? The left ammonia, that is 500 minus 100, that's equal to 400. Then how much nitrogen and hydrogen are there? So the ratio between ammonia and nitrogen, the ratio is 2 is to 1. So if we have 100 cm cube of ammonia reacted, x cm cube of nitrogen will be there. Cross multiply, so 50 cm cube of nitrogen will be there. And hydrogen, the ratio of ammonia and hydrogen is 2 is to 3. So if 100 cm cube, this will be x, cross multiply. So it will be 300 divided by 2. So this will be 150 cm cube. So basically, unreacted ammonia which is left is 400 cm cube, formed nitrogen is 50 cm cube, and formed hydrogen is 150 cm cube. So total volume of a gas 400 plus like unreacted, reactant and the formed product, so 400 plus 50 plus 150, so the total volume will be 600 cm cube. So C will be the right answer. Is it clear? Then question 29, a barium chloride reacted. Write an ionic equation. So to write an ionic equation, we cancel out the common ion. So chloride ions are common, that we cancel, and rest all will be there. So barium carbonate, 2 hydrogen ion gives barium ion, carbon dioxide and water. Two observation that would take place, no change in color occurred. So observation 1, what we observe, fizz, bubbles, effervescence, and the second, the solid dissolves. When acid is reacting with carbonate, a gas, carbon dioxide gas is there. That's why fizz, bubbles, effervescence, and the solid dissolve. In an experiment to prepare hydrated crystals of barium chloride, a volume of 25 cm cube of 2 mole per dm cube hydrochloric acid transferred and added until in excess. How many moles of acid were used in the reaction? So how many moles? We have the volume. So the moles equal concentration into volume. Concentration is 2 and the volume is 25 divided by 1000. So it will be 0.05. Then what is the mass of in gram? The total molar mass is given. So molar mass or mass in gram is equals to moles multiplied by molar mass. So moles are 0.05 multiplied by sorry, these are the moles of acid. Then we have to check the moles of basically barium carbonate, and the ratio between them is 1 is to 2. So from moles of HCl we'll get the moles of barium carbonate. First we'll use the ratio. So the ratio between barium carbonate and HCl when they react with each other is 1 is to 2. So if you have 0.05 moles, this will be X. So the moles will be 0.05 divided by 2, so it will be 0.025. And then we'll multiply by molar volume, molar mass. So 0.025 times 197.3, that will give us the mass in gram. That will be the mass in gram for barium carbonate, which will come out as 4.9 grams, 93 grams. When you write your answer, use three significant figure. Why an excess of barium carbonate is used in this experiment? So that all of the acid is neutralized or reaction is complete. How would you separate barium chloride solution from the reaction? So how we can separate? We use a technique filtration. The barium chloride crystals are left to crystallize. The crystals were separated and dried, and the total mass of a sample was 5.75. Calculate the percentage yield. So practically, this is the practical value. Theoretically, the percentage yield is a practical value. So we got the moles which were 0.05 or 0.025, basically the moles of anhydrous barium. That was a mass of barium carbonate. So using a mass of barium carbonate or moles of barium carbonate which were 0.05, we get the moles of barium chloride. As the ratio between them, barium carbonate and barium chloride is 1 is to 1. So if we have 0.025, this will be X, so we'll get the same moles, 0.025. And hydrated and anhydrous salt will have the same moles, only the molar mass will be different. So 0.025, the moles multiplied by molar mass will get the mass in gram for hydrated barium chloride. That will come out as 6.1. And then the percentage yield is a practical value. So practically we are getting 5.35. Theoretically it should be 6.1 into 100. So it will give us about 87.7% yield. Give one reason why the yield is less, even it does not contain any impurity. So maybe what happened, some of the, not all of the solid is crystallized, or maybe some of the product is lost during filtration. That's why lost or left on filter paper, or not all the solid crystallized. These are the reasons why we are not getting the 100% yield. And question 30, how many molecules are present in 16 gram of oxygen? So 16 gram of oxygen, so moles equal mass in gram over molar mass, so it will be 16 divided by 32, so it will get 0.5 moles. And 0.5 moles multiplied by molar number of the particle, because one mole is having 6 exponent 23. Like if you have 1 mole of oxygen, it will have 6.02 to 10 power 23 particles. So if you have 0.5 moles half, then it will be x cross multiply. So it will be 3 into 10 power 23. So D will be the right answer. Is it clear? Discussion. The number of the molecule, because they're asking for number of molecules. If it was number of atoms, then it will be twice. So this is the assignment related to topic moles and acid.